Today, we want to look at radicals, and we want to remind ourselves that radicals are just exponents. The big deal is that the index of the radical is the denominator of the exponent. That's how we connect the radical notation with the exponent notation. So square roots are usually not a new thing for folks that are walking into this class, but other roots might be. And so the square root symbol does not have an n. We don't write an n of 2 in our radicals for square roots. So in general, the important thing, and so here's the idea, the index of the radical is the denominator of the exponent. This is the thing that I told you to, or I asked that you remember to learn how to say. These are the words that go along with these symbols. The index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponent. So here we have the nth root of x. This is the radical notation, and the way we pronounce it is the nth root of x. So here is radical notation. And the way that you would read this is to say the nth root of x. So the reason I write it out this way is because that's how we speak this symbol. So if that is a 3, we would convert that to third root of x. If it was a 4, we would say the fourth root of x. If the index is a 10, we'd say the 10th root of x. So I'll write this out so we remember to not just say 3 root of x, we say third root of x. We convert it into a number. We get the ordinal out of it. So that's how we speak that. We say the nth root of x. We can also write it in exponential notation. We want to recognize that a radical, an nth root is a 1 over n exponent. The index of the radical is the denominator of the exponent. So we can also write this as x to the 1 over n. If we're going to write a fraction exponent as a superscript, write it sideways. So I think I talked about this on Friday. I like sideways fractions or up and down fractions for various things. I don't like diagonal fractions. I don't know, maybe I'm just weird, but diagonal fractions are, I think, poor communication. If you're going to write a superscript, make sure you use sideways fractions. So I think sideways fractions or horizontal fractions I think horizontal fractions are best for superscripts. If you put your exponents in superscripts, then I think you should use horizontal fractions. For single line syntax, horizontal fractions are the way, and we need parentheses. Always put parentheses in around fractions in single line syntax. So we have radical notation and two versions of exponential notation. The nth root of x is x to the 1 over n, or we could write it x to the 1 over n. That's how we're going to speak it. That is actually not a very clear way to speak it, but like we talked about with that weird order of operations problem, that is how we will commonly interpret that expression, because it would be weird to apply a strict reading of the order of operations to what I just said. When you say x to the 1 over n, you are saying that it's the 1 over n power of x. Also a bad way to say it, which maybe we're discovering why they started saying things like the nth root of x. I don't know how pedantic people were back then. I actually wasn't there. So when we say x to the 1 over n, we understand it's x to the parentheses 1 over n, or x to the quotient of 1 and n. But at that point, we're just sounding super pedantic. And even though it is accurate, we don't like it when people are insisting on that we be super pedantic. What I'm saying is that there's like this spectrum of proper speech. And so some people are like, oh, you're being so pedantic. And then on the same breath, they're like, oh, listen to the science, which is something you should do. But I just care that you recognize that people are being super pedantic when they say things like, well, that's not actually how you say x to the 1 over n. Specifically, it's like, be quiet, you know what I meant. But let's use parentheses around the fractions and single line syntax. And now that removes all doubt as to what we're attempting to communicate. Other things that we want to remember is that the radical will act as a grouping symbol. So parentheses is just one form of a grouping symbol. A radical will act as a grouping symbol. So the radical is a grouping symbol as well. The horizontal part of the radical symbol, the horizontal bar in the radical symbol, acts as parentheses. The horizontal bar of the radical acts as a set of parentheses. So for example, if I write the nth root of x minus 3, I don't know why n, I'm going to change it to a 5. The fifth root of x minus 3, the bar goes over the x minus 3. So this we would interpret as x minus 3 to the 1/5 power. However, if I cut the bar off after the x, if I have an expression that says the fifth root of x minus 3, that's an x to the 1/5 power, and then we subtract 3, because the radical bar stops at the x. The radical is not over the minus 3. The radical does not cover the minus 3, so the minus 3 is not part of the base of the 1/5 exponent. This makes it tricky to work with radicals because we have to be very clear about where the radical's horizontal bar ends. Sometimes we put a little ending on the x if we're going to write some stuff after it. And sometimes we're just like, oh, well, I don't want to risk it. So sometimes we'll just switch the order to avoid confusion. Oops. To avoid confusion, we have a few strategies. We can mark where the radical ends. That's a good way to phrase it. We could write the radical by saying the fifth root of x minus 3. So sometimes you'll see a little drop at the end, not all the way down, but just like a little drop at the end. And then that says this is the end of the radical. So sometimes you'll see a small drop at the end of the radical to indicate where the radical ends. Another strategy we might employ is like, oh, let's just write the radical last. So just write minus 3 plus the fifth root of x. Just make the radical the last thing in the expression, so it's very clear. There's nothing, we can see nothing after the x. So that would be a more radical solution to the problem. And of course, we can always avoid confusion with our famous friggin' use parentheses. This looks excessive. That's the problem with this particular solution. That's not really a part of it. It's just, this looks a bit excessive. Further along you go, when you all are in calculus, if people are still writing parentheses around their x, like, oh, this looks kind of, that looks like excessive amounts of notation. Do I really need that, or is there a better way? Usually, where the radical ends is not a problem when we're typing things. This is an issue for where we're writing things. So when you're typing things online, or actually just when you're typing things in general, it's not a problem, because when things are in print, it's usually a little more clear where the radical ends, because we'll insert more space between the end of the radical and the start of the minus sign. So usually it's more clear when things are being typed. But if we happen to be writing things, so the way that this looks a little bit excessive is like, I guess it would be like writing 1x instead of x. We know that when we just write x, we mean 1x. And it's okay, and it looks weird if you're later in your math career and you're still writing 1x. It's like, oh, that seems strange that you would write that. It's super normal to do in an algebra class, because you're reinforcing the idea that x by itself means 1x. Because I just did 5x minus 4x, and I want to know that that's 1x. And then later, we can incorporate the cultural aspect where we say, oh, we just write x when we mean 1x. And it's like, I'm going to start doing that because I want to fit in and be cool like everybody else. You know what I mean? And then people can criticize that if they want, oh, why are you trying to be so conformist? And it's like, well, because we're trying to communicate. And so we have to have an agreed upon set of rules. You know what I mean? I don't care what color you dye your hair. I won't hold that against you at all. That is just a normal thing now. And anybody that's like, oh, this applicant came to my job interview with blue hair. It's like, oh, blue hair is normal now. So it's okay. I have these people coming for job interviews and they're always wearing these like stupid 3-piece Brooks Brothers suits. And they look ridiculous because I grew up on the West Coast. But then again, if I went to the East Coast, people would be like, oh, this guy came to the interview, this Leach guy came to the interview, and he wasn't even wearing a friggin' suit. What's wrong with these people from California and their no suit wearing things, no suit wearing ways? You know what I mean? Incidentally, the only reason I'm not wearing a suit in that scenario is because I don't actually own one. I just realized that I don't own a suit. That's like a California thing right there. It'd be like driving to the taco truck that's like a block and a half away. Like, oh, but I have to go like, I walk to the end of the block, then walk another 2 blocks down, and then walk another half a block. It's ridiculous. I'm just gonna drive. That's a California thing. And I'm not gonna wear a suit while I'm doing it. Not making fun of you if you like suits. You know what I mean? All right. What are we talking about? Oh, yes. So we talked about, now I got to remind myself of where I was going after this. So this is all, so far we've been talking about the notation, because this is an important aspect because we're trying to create a written communication for these ideas. Radical notation is the nth root of x. We write that with an exponent 1 over n because the index of the radical is the denominator of the exponent. We want to understand that the radical is a grouping symbol, that the horizontal bar acts as a set of parentheses to tell us what is the base of the fraction exponent. What is the base? What is the radicand of the radical? One thing that this allows us to do, this is kind of a niche problem, but not really a niche problem, but it will turn into a niche problem. So simplifying radical expressions because radicals are fraction exponents, simplifying radical expressions turns into simplifying fractions. Simplifying radical expressions turns into simplifying fractions. So what I mean is, if we've got a cube root of x to the 12th, the index of the radical is the denominator of the exponent. So this is x to the 12 raised to the 1/3 power, or we might say x to the 12 to the 1/3 power. Or we might do some weird kind of hybrid where we write x to the 12, it's like all superscripts. And then we're like all to the 1/3 power, single lines. So when we raise an exponent to an exponent, we know we multiply the exponent. So this is going to be x to the 12 divided by 3. And so that's going to be x to the 4. So the cube root of x to the 12th, the index of the radical is the denominator of the exponent. The index of the radical is the denominator of the exponent. So simplifying radical expressions is about simplifying fractions. So for another example, if I have the fifth root of x to the 10th times y to the 20th, that's going to be an x to the 10 over 5 and y to the 20 over 5. The index of the radical is the denominator of the exponent. So it's going to be x squared y to the 4th. The index of the radical is the denominator of the exponent. We might be mixing some coefficients in here. So we might see an expression like the cube roots of 8x to the 12. And here the radical bar extends over the 8 and the 12. The index of the radical is the denominator of the exponent. What we have to recognize here is that 8 is not an exponent. Eight is not an exponent. We're just trying to figure out what the cube root of 8 is. But the cube root of x to the 12th we can deal with in the exponents. Now, the reason I can do this is that a radical is an exponent. 8 times x to the 12th is a product. And exponents distribute over multiplication. The cube root of 8 is 2, not 8/3, because 8 is a coefficient and not an exponent. The cube root of 8 is 2. Because 2 to the 3rd is 8. That is 2 times 2 times 2 is equal to 8. The cube root of x to the 12th is an x to the 4th like we had before. Any questions? So the first go around, I always use multiples of the index. What if the exponent is not a multiple of the index? That's a concern. So here's a concern. What if the exponent isn't a multiple of the index? What if we had an expression like, instead of, we had a cube root, but not of x to the 12th, it was x to the 14. We want to simplify as much as we can, especially if we've got a power like to the 14th. That's too much. Not for modern computers, but. So the cube root of x to the 14th, I can think of this as x to the 14 over 3. Because the index of the radical is the denominator of the exponent. And we know that 14 over 3 is 12 over 3 plus 2 extra. We can think of 14 over 3. 3 goes into 14 4 times with 2 left over. So I can have x to the fourth with no radical. And what's left over is 2x's in a cube roots. And sometimes this will be considered the simplified form. Another way we could think about it, so this I wrote the problem this way because I wanted to think about the index of the radical being the denominator of the exponent. We can also think of this in terms of exponents distributing over multiplication. We also might look at the cube root of x to the 14th and say, well, 3 goes into 14 4 times, and that's going to be 12. So I'm going to say this is the cube root of x to the 12th. I'm going to pick the 12 because I can divide 12 by 3, and then I have 2 left over. The cube root of x to the 12th is x to the 4th, and I still have this cube root of x squared left over. Notice that all the thinking that went into splitting the 14 into 12 and 2, it's the same thinking that goes into 14 over 3. So however this is taking place in your mind, it's all the same. It all comes down to that basic skill that we learned way back in the halcyon days of whatever grade you're in when you learn fractions. I probably should know that, but I don't. But I know that at the time that you were learning fractions, one of the classes you were taking was like recess, where it's like, all right, everybody, go out and play. And I think it's unfair that in schools centered around adults, it's like, oh, why don't I have that class? Then we have to remember that there is that class. It's like you have a 9 o'clock class and an 11 o'clock class. That means you have 10 o'clock recess. It's just that no one ever just goes out onto the lawn and plays tag or something like that. Because for some reason, we consider that not to be an adult thing to do. Oh no, look at those young people playing tag. Who do they think they are? Children? Yeah, that would be part of my payment plan. Because remember, my plan is to not make tuition free, because that still means it could be free and you just can't afford to go. Remember, I'm paying you to go to school. And so one of the things that since I'm paying you, I want to make you as an effective employee as possible. And one of the ways to make you an effective employee is to keep you from studying constantly. So you get paid to go to school from 8 to 5, even though you're only going to be spending 3 or 4 hours of those hours, 3 or 4 of those hours in class. There's definitely going to be some times where you're on a break. And so you like show up at my office and I call, hey, Professor Leach, I have a question. And I'm like, aren't you on break? And I go, yeah, but I'm like, then get out, go outside. I heard there was a game of tag out there. Go join in. You know what I mean? You got to shut it off sometimes. It can't be all work all the time. If you believe it needs to be all work all the time, that just means you've been infected by the toxic work environment that we've created in our society. You know what I mean? We consider it acceptable that someone's got to hold down like 3 full-time jobs, actually more like 4 part-time jobs to make ends meet. Try it and see what happens is what I think our society should be all about. We could sit there and we can have concerns about, oh, but if we do that, then this will happen. It's like, well, we haven't done that. Why don't we prove to ourselves that that is the case? Because if we try this, if we try Leach's plan, where we all get together, pool our money, and just pay students to go to school. Why don't we try that? If it doesn't work, I'd be more than happy to say, okay, it didn't work. let's try to figure out something else. But to do things the way that we've always done them is stupid. If we did things the way that we've always done them, then I see a couple people on this list of names that wouldn't be in this class. Oh, I see 3, 4, I see one person on the list of 5 names that would be in this class. I'd be here all by myself for various reasons. This is based on this. I can't see you, so I'm just making just guessing based on the names that I see. If we do things the way we've always done them, then some of you wouldn't even have the option to go to school. You know what I mean? And that's bad. I don't want to force people to go to college. But if a person says, I want to go to college, I want them to be able to do it. I want them to have that opportunity. You know what I mean? And when I say I'm going to pay you to go to school, I'm not going to ask for anything afterwards. I'm just going to pay you to do this. If you and because some people are like, oh, pay people to become engineers. Like, oh no. If they want to go to school, if they want to spend their time in college studying art history, I'm okay with that. I think that's great. I think that's kind of the point of an organized society. I don't like the idea that we think we have to get something out of you in order to, I don't know, give you the resources that you need to, what's it called? Survive. I have the same feeling about parenting, which is why I don't have a kid. I don't like it when parents are like, oh, the kid owes me something. It's like, well, no, the kid doesn't owe you anything. They're brought into existence without their consent. This is your vanity project. So put in the work, parents. You signed up for this. The kid didn't sign up for this. If your kid is sassing you, you taught them to sass you. Probably by sassing your kids. If you treat your kids with respect, that's what they're going to learn. On a related note, this is coming from a position of great privilege on my part. My parents are great. They taught me treated me with respect, and I firmly believe that that's why I respect them now. I don't owe my parents. Whenever my mom needs to do something, I am right there. Not because I owe her, but because we respect each other. And she's like, well, hey, can you drive me to this place? I'm like, well, yeah, no questions. I'm like, well, absolutely. Not because she demands it from me because I'm the kid. Not because she brought me into this world, because she brought me into this world against my consent. I did not say, yeah, I want to be alive. This is their vanity project. I am their vanity project. You know what I mean? Anyway, that's neither here nor there. And that try it and see what happens is in the chat. Try it and see what happens is all I ever want. I know that this is a big lift. It's like, well, I think this would be really awesome if we just straight up pay people to go to school. They don't have to have another job. We just pay them to do it. And the amount that we need to pay them needs to cover all of their basic needs. They need to be able to have shelter. They need to be able to have food. And I don't know, what other needs are there? They need to be able to chill from time to time. And I'm not talking about subsistence food. I'm not talking about living on top ramen. I'm like proper, balanced diet. That's how much I want to pay you. $15 in 2024 is just status quo as far as I'm concerned. The latest estimate I've seen, it's like $37 now. And then we can apply inflation to it in 2024. I've seen estimates that a proper living wage in the United States
Anyway, that's all beside the point. We're just trying to learn to read radicals. But the big advantage that we have is that radicals are just exponents, and we spent a lot of time looking at exponents, so we know how that stuff works. Exponents distribute over multiplication. So if we're clever about how we separate our multiplication, we can be clever about how we distribute our exponents. The index of the radical is the denominator of the exponent. So maybe we're like, oh, now let's not split things up this way. Let's go back to the old things that we already know. 14 over 3 is 4 2/3. 14 over 3 is 4 2/3 because the index of the radical is the denominator of the exponent. Any questions? There was one that I didn't get to talk about because we're out of time. Is like the fourth root of x squared. But if we remember the index of the radical is the denominator of the exponent, we will know what to do for this expression. All right. That's it for today. I will see you all next time on Wednesday. It won't be until Wednesday. So I'll see you all on Wednesday. That's it for today. Everybody have a good day, and thanks for playing.